Okay. This is chapter 3, section 4, problem 21. The accompanying data represent miles per gallon of a random sample of cars with a 3-cylinder 1.0 liter engine. Part A, compute the z-score corresponding to the individual who obtained 36.3 miles per gallon. Interpret this result. Part B, determine the quartiles. Part C, compute and interpret the interquartile range. Part D, determine the upper and lower fences. Are there any outliers? So they give us data here. So we click the data. We can open this in StatCrunch. So we have our data. So according to this, we can go to stat and summary stats and columns. Okay. Select column var 1 and then press compute. So it gives us what we're looking for here. So the first part here, find the z-score. So we're going to standardize the distribution to have the same numbers here. When you standardize the distribution, you can compare between different samples and different populations when they've been standardized, and actually talk about which one is smaller or larger, relatively speaking. So we have our formula for the z-score. Okay, and we have our value. And they give us the mean to be 38. And they also give us standard deviation. So we can plug in here and find out what our z-score is going to be. We end up with a negative 0.72. So the quartiles here divide the data into 25% portions. The first quartile divides the bottom 25 from the top 25%, 75%. Okay. The second quartile divides the bottom 50 from the top 50. So the second quartile is equivalent to the 50th percentile, or the median. Finally, the third quartile, Q3, divides the bottom 75 from the top 25. Okay, so the third quartile is equivalent to the 75th percentile. Or the median on the top half of the data. So it asks us to determine the quartiles. So you can see here from the data, we see the first quartile is at 36.85. So that's a 25. Below that is the bottom 25%. Q2 is the median. So is the median that divides the bottom half from the top half. Q3 is given here. Okay, that divides the bottom 75% from the top 25%. Okay. And they ask about the interquartile range. Now, the interquartile range gives us that middle 50%, where the middle 50% of the data will be located. And that's found by the difference between Q3 and Q1. So we have 40.85 minus 36.85. So the interquartile range is where you're going to find where most of the data, 50% of the data, is going to be. That's the range for the data. It's going to vary that much. You'll find 50% of the data is going to lie within that. Now, the fences are cutoffs for determining outliers. So the lower fence is going to be, the lower fence is going to be the first quartile. Minus 1.5 times IQR, and the upper fence is going to be 1.5 times the IQR. So there's our lower fence and our upper fence. Okay, we've done everything here but show you what an actual box plot looks like. So if you look at this again, so you can look at Q1, it's here, Q2, it's going to be the median, which is at 38.4, and Q3 is 40.05, 40.85. The interquartile range is going to be the difference between here. So each one of these represents quartiles of 25% of the data. So you get your bottom 25 here, your bottom half is here, your bottom 75 will be here. You have a middle 50% of the data, which is called the interquartile range. Which is going to be Q3 minus Q1. So 50% of the data is going to fall between that. Okay. In this case here, we have 40.85 minus 36.85, which is 4 miles per gallon. So 50% of the data is going to fall between the 4 miles per gallon there. Okay. So when they do that, they have the fences here, cutoffs for determining the outliers. So we want to determine those. So my lower bound is going to be Q1 minus 1.5 times IQR. And the upper bound is Q1, and this is Q3. plus 0.5 times IQR. Okay, so what we end up doing here for the lower fence, we have 36.85 minus 1.5 times 4, which gives me 30.85. And for the upper fence, I have 40.85 plus 1.5 times 4, which gives me 46.85. So 30.85 would be here, and 46.85 would be here. So anything beyond this, beyond the 46.85 and less than the 30.85 is going to be considered an outlier. So in this case here, we have in the data set, we have a 47.6. So 47.6 is a outlier. Yeah. And that's called a box plot there. And that will be somewhere out here, the outlier by itself. 47.6 is the outlier.